Okay, pretty long, because
Okay.
it's graph. 8.2, graph simple rational functions. Okay, a simple rational function is in the form of f of x equals p of x over q of x. Okay, the parent function is f of x equals 1 over x. So a rational function has a fraction in it, okay? 1 over x in this case is the parent function. Now, when you have functions like this, you have something called a vertical asymptote and a horizontal asymptote. Okay, here my vertical asymptote is x equals 0. It is not crossing this line of x equals 0. My horizontal asymptote is y equals 0. It will not cross this line of y equals 0. Okay, my graph has a mirror here and it mirrors over here. So here's the deal. When you are graphing rational functions, you're either going to have graphs like this, one here and one here, or you're going to have one here and one here. Okay, now later on we're going to talk, they can shift and do all that fun stuff because your asymptotes will shift. But right now, it's these quadrants or these quadrants. You will always have two pieces to your puzzle. Okay, two pieces to your graph.
So the one on the top right is vertical? No?
Your vertical asymptote is the fact that if I drew a line at x equals 0, it would be right here. It does not cross that. Do you see how when this graph comes close to that, it just turns up? And this graph comes close to that line, it turns down. It's never going to cross that line. That's what an asymptote is.
Okay.
Your horizontal asymptote is y equals 0, which is the line that goes horizontally, and it's never crossing that line, and it's never crossing that line. It will continue to get smaller and smaller decimals, but it will never cross that line. Okay? So, when we input a 1, okay, into this graph, you get a 1 out, right? 1, 1. If I input a 1, I get a 1 out, 1, 1. Okay, if I input a -1, I get a -1 out. Actually, let's make that right there. Okay, so that means 1, -1. Okay, so that's what's happening here. Okay, that's my parent function. Now we're going to graph just a standard graph. We're going to graph the function y equals 6 over x, and we're going to compare it to the graph with the graph of y equals 1 over x. If I graph this parent function, let's say I'm going to graph this one in pink, the parent function. When I plug in a 1, I get a 1 out, right? When I plug in a -1, I get a -1 out. When you plug in a 2, you get 1/2, or you get a half, right? So it goes there. When I plug in -2, I get -1/2. When I plug in, let's see here, 3, I get
Oh, this is inverse.
1/3, right? And so on and so
Well,
forth.
because you have to do
Okay.
negatives and positives.
So my graph looks like this. This is my parent function again, boom, it runs along that line, and then it runs along this line, right?
So you're gonna have, okay, so you
This
have,
is my parent function.
so you're gonna have 2.
Yes, because it says compared.
Mm-hmm.
And you're gonna have 2, one on the top and one on the bottom, okay? Now, this, I have to plug numbers in, okay? So the first step is to draw your asymptotes. You always wanna draw your asymptotes. What is my asymptotes in this case? What do you think they are?
Wouldn't it be x equals 6?
Mm-mm.
Well, it would be y equals 1.
Nope. What is this graph not crossing, the parent function?
Oh, 0.
So did I add or subtract anything to this function?
No.
So my asymptote is still going to be
Oh, 0.
0,
Oh.
okay? So draw asymptotes means I'm putting dotted lines at my asymptotes like this. So that I know that my graph cannot cross those places. So x equals 0 is my vertical asymptote. Y equals 0 is my horizontal asymptote. You have to label those things for me. Okay? Second step says plot points to the left and to the right of the vertical asymptote. Okay? So step 2, plot points. That means we have to plug numbers in, yes? Okay? So, let's plug numbers into this. If I plug a 1 into there, what do you get? 6. So 1, 2, 3, 4, 5, 6. 1, 6. If I plug a 2 into there, what do I get?
3,
3. If I plug a 3 into there, what do I get?
2,
2. And let's say I plug a 6 in, what do you get?
1.
1. So this is the graph of y equals 6 over x. Now, I still have to plug negatives in. If I plug a -1 in, what do you get?
-6.
-6. If I plug a -2 in, I get -3. If I plug in a -3, I get -2. And if I plug a -6 in, I get -1. Okay, so these graphs should always mirror each other. Okay, there we go. And the third step was to draw it. Okay, that's how we graph and compare. Okay, now, this is where the problem comes in for us, okay? But the same rules apply on this graph as anything else. Do you see this extended version?
Yeah.
Y equals A over X minus H plus K, where A is my constant, right? X, stays there. What do H and K do to my graph always?
Shifted.
They always shift it, okay? H is always opposite of what it is, K is always true to what it is, okay? So, once again, you're gonna start with the same steps. You are going to draw the asymptotes. Okay, here's how you can tell what your asymptotes are,
Okay, I see.
okay? You have to look at what's with the X and what's with and what's on the outside, because that's your Y. So what's with the X?
Wouldn't it be x equals -2?
It would be. So my asymptote is opposite of this, so it's X equals -2. What is my Y asymptote?
negative.
-1, okay? So this would be my vertical, right?
Yeah.
And this would be my horizontal, okay? Those aren't too hard to find, I don't think, okay? So I would come to -2 and I make this. No, I don't. -2 is my vertical one. I come to -2 and I go like this. There's one of my asymptotes, okay? I go to -1 and I go horizontally. So now, instead of it being that my quadrants are here and here, like on the regular axes, my quadrants become here and here, or here and here. Does that make sense? So I make new parameters, okay? So I'm either gonna graph stuff here and here, or I'm gonna graph stuff here and here. And it's never going to touch -2, and it's never going to touch -1 for the Y. Okay? Next, we need to plot points. Here's how we do that. We literally go here, and we pick 1, 2, 3 numbers and plug them in. We pick 1, 2, 3
Please
numbers
excuse
and
this
plug them in.
interruption. I need 7th grade with the last name T, as in Benjamin Tiley, to W, as in Wilson, to come to the front lobby.
Okay, so let's do it this way. I'm gonna just keep erasing what goes in here. Okay, so let's plug things into X. Let's start on the positive side, well, positive side, but it's not. Let's start with -1, okay? If I plug a -1 in here, I get -4 divided by 1, right? What's -4 divided by 1?
-4.
-4, and what's -4, minus 1?
You said minus, it was -1?
Yeah, because it'd be -4 minus 1.
Oh, then, -5.
And -5. So when I put in a -1, I get a -5 out. Okay? Which means my graph is gonna be here and here now. Does that make sense? Okay. Let's put in let's put in a positive 1 now, okay? Change this to +1. What's -4 divided by 3? -4 thirds, which is -1 1/3, right? And what's -1 1/3 minus 1? So like -1 1/3 plus -1.
Oh, -1/3.
Mm-mm. -1 1/3 minus 1. no, it won't read it on there. Watch, you're gonna have this, -1 1/3 -1. What do you do with two negatives? You just do what with them?
What you add?
You add them, so what's -1 plus -1?
Oh.
-2 1/3. Don't let the third fool you. -2 1/3, okay?
I don't like this.
So you go to 1, -2 1/3. So right about there, okay? And then I'm gonna plug in 3 also, just to give me 3 points. I want 3 points on each side. Okay, so let's plug in 3. 3 plus 2 is 5, right? What's -4/5? So I get -4/5. -4/5 minus 1 gives me what? Just combine them.
That would be -1
And
with 4/5.
all you have to do is combine them because they're both negatives. So I go to 3 and I go to -1 and 4/5. So something like here. So my graph is gonna look something like this. Okay? Now we come over here and plug numbers in. I'm gonna plug in this first number, which is -3. Okay? So we plug in a -3 now. -3 plus 2 is -1, yes? What's -4 divided by -1?
4,
And what's 4 minus 1?
3.
So -3, 3 is my point. -3, 3. Now I'm gonna plug in -5, and then I'm gonna plug in -7, okay? So let's plug in -5. -5 plus 2 is 3, -3, right? So -4 divided by -3 is just 4/3, right?
Mhm.
So what's 4/3 minus 1?
Wouldn't that just be 4/3?
Watch, 4/3 is actually 1 1/3. What's 1 1/3 minus 1? 1/3. Okay, so I go to -5, and I go to 1/3. Okay, now I'm gonna go to -7, I'm gonna plug -7 in. -7 plus 2 is -4, right? What's -4 divided by -4? That's an easy
1.
question. 1. What's 1 minus 1?
0.
Beautiful. And I put -7, 0. Here's this graph. That's how we're graphing those. Does that make sense?
Please excuse this interruption.
Now.
I need Gracie Conley and Aya Johnson to come to the front lobby.
Anymore.
I need
She
ninth
has to
grade,
pick people
Carter
that need to be
Abner.
tested.
A as in Abner,
Right.
B as in Gramble to come to the front lobby. If you
Now,
wear glasses, please
state
bring them. Thank you.
Domain and
I hate
range,
this one was.
okay? So
Domain.
not only are we giving vertical and horizontal asymptotes, we're giving domain and range. We will clearly spend more than one day on this. Okay,
That's fine, I'm good.
domain. Here's how you find your domain and range. It's very simple. You look at your asymptotes.
So it's the opposite of that?
No, okay? So my domain, what does it never cross?
-2.
-2. So my domain is all real numbers except -2,
Ooh, okay.
okay?
So
So
we
it's
just write that?
all real numbers except -2. Domain and range is easy on these. My range does not cross,
-1.
so it's all real numbers except,
-1.
okay? So if you can find your horizontal and vertical asymptote, you can find your domain and range.
To the asymptotes.
I'm not worried about that.
Yes,
I get
the
points,
asymptotes
right?
are your domain and range.
So no matter I have.
Because that's the only thing it cannot touch are those asymptotes.
The asymptote is basically just what the parent function is, right?
Your asymptote
Oh,
is what
yeah.
is added or subtracted to
Yeah.
the equation with your x and y, okay? So if there is nothing here, your y asymptote would have been 0, okay? If there is nothing here, your x asymptote is 0. okay? If there's stuff there, the X is opposite of what it is, the Y is the same.
And so if it were the case where the asymptote was 0, would you just say all real numbers except 0?
Yep.
Okay.
Yeah, exactly, okay? That's what we're gonna do today, so you can have some time to work on this, but we'll also do more of this tomorrow. We're not gonna learn another lesson tomorrow, we'll do more graphing tomorrow, okay?